will take steps towards my goal of achieving 100% carbon pollution-free electric sector by 2035.
Transition to a green, sustainable future is a new trend of the 21st century.
We've set the goal in 2030 to reduce greenhouse gas emissions by at least 55%.
According to the European Green Deal, Europe aims to become carbon neutral in 2050.
We aim to have CO2 emissions peak before 2030 and achieve carbon neutrality before 2060.
The transition to renewable energy will require lots of different metals. The pressure on the mining industry will multiply. And Sweden, as a leader in mining in Europe, takes steps to make the industry more efficient.
The mining industry needs to be more productive, and we are outlining an organization that can help to test and develop new mining-related technologies.
Mats Johansson is the leader of the mining development project called SMIG. The project is financed by the Swedish government agency Vinnova. Through PIIA and Swedish Mining Innovation and mining-related companies, it aims to increase mining productivity and safety.
This partnership is profitable for all actors in the industry. The universities get access to resources to speed up their research. SMEs can commercialize innovations easier. OEM suppliers can easier get new solutions to the market. And mining companies can early utilize innovations in the order of the goal to achieve a fully automated mining operation. This collaboration reduces risks and testing costs, and the Swedish government potentially gets more taxes and a more efficient industry with new jobs.
Founded in 2019, the SMIG project has already helped several mining-related companies, IT companies, and universities.
And we have also studied how the project can support various players to work together based on several use cases.
Thanks to its large reserves of natural resources and world-class innovation policy, Sweden is a world leader in the mining industry. But the development and testing of new technologies can be a difficult task, even in Sweden, especially for small companies and academic teams.
If you want to be a supplier to the mining industry, your customers need to know that your technology is actually working. And to be able to do that, you need to test and demonstrate that technology. But if you are a smaller actor, like an SME, an academic team, or an actor completely new to mining, you have a hard time getting access to operational sites.
One of the goals of the SMIG project was to analyze the potential of a central test and demo organization and determine the role it can play as a testing facilitator to accelerate innovation in the industry.
We have mapped over 150 actors related to test and demo in Sweden. And this decentralized network of different actors makes it really hard for smaller and new players to navigate the infrastructure for test and demo to find the best suitable solution for the TRL acceleration needed for their innovation. This is why SMIG as an organization is so important as a single point of contact for various actors, simplifying the complete processes for test and demo.
The next step was to understand how the project would get financing. Factors of risk and success were analyzed, and different benchmark cases were studied.
What we have learned is that SMIG and similar organizations have a really hard time operating solely on a commercial basis, because these test sites and also the actors that need to perform the tests have very small budgets. So to be able to make SMIG a reality, we believe that we need to have public funding for it. And we have already now identified potential investors and partners to be a part of the SMIG project further on.
Lisa and Nicholas have dialogues with the Swedish Mining Innovation, the government's strategic innovation program, which is interested in financing SMIG as a 3-year project.
So the need for SMIG is clear, and it's really positive that several actors have identified this need as well as we have. But we still have a lot of steps to take to make SMIG a reality, and we will work on that in this short time.
We have a time window until August 2021 to find suitable use cases and in-kind contribution from the industry.
So if you have invented new mining-related technology and you want to test and demonstrate this, don't hesitate to contact us because we know exactly how to do that.
By creating a single point of contact organization, the SMIG project will focus on a dramatic increase in the level of innovation in the Swedish mining industry. And it has already proven to be effective. During the SMIG project, several mining-related companies got access to test sites and were able to get help from the industry experts. We'll tell you about Luleå-based company called ThingWave and its use case.
My name is Jens Eliasson. I'm the CEO of ThingWave AB, and we are based in Luleå, Sweden. In ThingWave, we are working with what we call the digitalized ground support, which is a breakthrough technology for making mines safer, both for workers and equipment. It's based on IoT solutions, where we put very small and low-cost wireless devices with different type of sensors, and then we can measure anomalies and alert the mining companies about pending danger. Since we are working with sensors, we do need access to real mines in order to do field tests. And before SMIG, we had to run around and speak with different mining companies, but during the SMIG project we got much easier access and we could start doing a lot more field testing to test our new technologies.
ThingWave has been leading the use case digitalized ground support, aiming to develop new solutions for ground support monitoring. Together with data analytics from Uppsala University and experts in rock mechanics from Boliden AB, the ThingWave team has improved its technologies and measurement performance.
In this collaboration, we managed to create a couple of different results. One result was regarding follow ground detection that we have been working with together with Uppsala University. We sent them data that we managed to collect together with Boliden in the Kristineberg mine. And they were actually able to write algorithms that can detect even when small events happen close by smart rock bolts. So this is one important result from the use case. Another result is that now we can detect different properties from rock bolts, including strain and elongation, breakage, and microseismic activity. We also worked a lot with the data integration. We have created software systems for the Arrowhead framework, where we can both send and receive sensor data using an Arrowhead local cloud. The SMIG project has helped us to get quick and easy access to mines so we can perform field testing, which for us is very important since we do work with hardware. We were also able to meet new people and companies that we can work with, and it's been a great pleasure to work with SMIG with all these great people.
New sensors and technologies generate data, and it must be handled by existing industrial systems. To achieve information exchange between participants, Benerit was invited to the SMIG project.
Hello, my name is Hans Forsberg. I work at Benerit, has been working there for about 20 years. The company is stationed in Luleå and has about 35 employees and work mainly with software development. Benerit is a company that works with other companies, and SMIG was a great opportunity to get new companies to work with and help them with integration problems.
In the SMIG project, Benerit worked with the Arrowhead framework, an integration platform that simplifies information exchange processes. The company also used its software, Arrowhead Test Tool, to verify each integration.
Together with use case 3, we had actually done a proof of concept where we showed how the information from the rock bolts has been integrated actually to Benerit's test tool. In use case 5, we have worked mostly with the documentation model to see what the further development should be after this project. We also work with all the other use cases. Some use cases we have worked with the documentation models, and in some use cases we have worked with information exchange and have their system fully integrated. Our achievement in this project is to actually get to know a lot of other companies that we can continue to work with after the project. The other achievement for us is that we actually have the opportunity to work with our test tool that is a platform for verifying system of system. I'm very grateful for the collaboration in the project, and I think that we have achieved a lot of things with working with other partners, and hopefully we will continue to work after this project with these partners.
Underground mining is a challenging process, and it can be dangerous for workers. To make the industry safer, mining companies are planning to reduce the amount of underground personnel, including drivers of the vehicles. And Allegory Simulation, the participant of the SMIG project, works towards the goal to make the underground fleet fully autonomous.
My name is Martin, and I work as a R&D engineer at Allegory Simulation here in beautiful Umeå. Developing autonomous systems and training them using simulations will be a big part of the future. Our simulations can be used to train machine learning algorithms, but we require the help from other companies to actually implement this on real vehicles and do the verification and the testing on real vehicles. And the SMIG project has given us that opportunity to work with companies who work with real vehicles.
During the project, the Allegory's team intended to work with Boliden and Epiroc to develop machine learning algorithms, train them into a simulation, and apply this technology in a real mining vehicle.
But because of the pandemic situation, we had to concentrate our work on the software part. We were able to make a proof of concept implementation of a machine learning algorithm on a V-loader loading cycle, which is the main result of our part in the project. We have also developed a framework and a workflow for continuing and developing these machine learning algorithms for other vehicles as well and other applications. So that's what we hope to do in the future. And the SMIG project has allowed us to further understand mining operations and vehicles and allowed us to work with great companies. It has also been a way of getting to know better the mining industry and also getting to know what it's like to work in a big project like this with many different participants, experts in their own areas, and that we all can contribute something. It's been a great experience.
To fulfill the demand for metals and minerals, the mining industry has to become more efficient. And the high-quality long-hole drilling use case has already made a significant leap towards that goal.
My name is Fredrik Gabrielsson. I represent Epiroc, the Tools and Attachment Division, where I hold the position as Marketing Manager Digitalization. Our headquarters is based in Fagersta, and Fagersta is in the heart of Bergslagen, which is the cradle of Swedish industry, and also where we have some of the oldest mines in Sweden. I was responsible for the use case high-quality long-hole drilling, and this use case was executed together with Boliden, and the objective was to significantly increase bench height in a mine, so get a lot more material out from each blast.
During the SMIG project, Epiroc developed a brand new technology and equipment. A mining company, Boliden AB, provided test facilities and operators to run the equipment, and Benerit assisted with the Arrowhead framework.
SMIG project presented a common objective to make it easier for, first of all, I would say, several functions within the same division, but also several functions between divisions. And on top of that, we had a customer that helped defining the goal and presented true value in what we were trying to achieve.
Epiroc managed to develop CoProd Underground, a new mining technology with a 50% faster penetration rate compared to the conventional tube drilling system, with incredible accuracy. This technology will nearly double the amount of material in one blast.
To me, SMIG is a forum and a platform where several actors are being presented to each other and are working together, where we can share knowledge, information, and also, in some cases, even resources to move forward. It's been a great experience participating in the SMIG project, not only doing things in a new way, and not only because it was the first time I had full control and access to the data I need in my daily work, but also due to partnerships and collaborations with other companies and stakeholders that were participating in the project.
New technologies are often developed in academic teams. Uppsala University, ranked among the world's best research universities, participates in various development projects, including SMIG.
My name is Monika Ivantic. I'm a geophysicist and I work here at the Department of Earth Sciences at Uppsala University as a researcher. In the SMIG project that we are now currently working, we are testing the seismic wire drilling technology. We are attempting to bring it to the more automated level, as well as we are testing in a real environment our numerically verified method for monitoring drill bit trajectory. It's very difficult to find a test site where a drilling process is happening so that we could use drilling noise as our seismic source. It's usually difficult to convince companies to collect data during their drilling processes for the benefit of the research. So SMIG has allowed that, and it was a fantastic thing. I will show you some of the instruments that we used in the SMIG project. So these are the wireless units that we use in the field. They measure seismic activity. These are the images that we get first when we collect data. Then we apply different processing workflows to get something that looks more like conventional seismics and can be used further for interpretation. In this use case, we collaborated with Epiroc rock drills, and it was a great collaboration, and I think both sides benefited from it. For the test site, we used the test site near Epiroc factory in Örebro. This test site was basically meant to be used for testing different drilling technologies, so it was excellent for our method as well. And in August 2020, we did a field test where during the drilling we laid out the instrumentation, collected very good data.
The data from geophones matched the data from the active seismic study and the synthetic modeling results, and they'll be further used to improve the technology. During the project, the seismic imaging while drilling method has produced promising results, and the work on the study will continue.
SMIG for me personally is an excellent experience where I had a chance to work closely with industry, with companies, to learn problems they deal with and how they solve them, as well as had a fantastic experience of developing our own numerically verified method in a real test environment.
COVID-19 has changed the life of everyone. Due to the pandemic restrictions, it became impossible to work the way people are used to. The SMIG project was also affected by COVID lockdown.
COVID has affected everything in most of our lives.
It did create some challenges.
We were hit quite hard from COVID.
Due to the COVID situation, our field work was delayed.
COVID pandemic has certainly affected our possibilities to meet and also to utilize the testing sites.
In order to get real data, we need access to real mines. And during the outbreak of the pandemic, every mine basically in the world closed access to visitors.
And we have been working from home for more than a year. It has been hard not getting to meet fellow co-workers and meet other participants in the projects like we were supposed to do.
Cooperation between the companies has suffered a bit, and we probably have gone a bit farther in the project if the COVID didn't occur.
Yeah, it's also why we're sitting here outside today instead of in some conference room.
Despite various limitations and difficulties, the SMIG participants managed to succeed in their use cases and achieve some of their goals. They are looking forward to continuing their work and waiting for the opportunity to test and demonstrate their technologies.
It has affected the things we do, but not so much how much we did. We just had to focus on different areas.
Luckily, we have always alternatives that could also contribute significantly to the project. So we focused on modeling, so more computer-based work.
We actually had to change a lot of our plans, and we started to do a lot more lab testing. But we also started to develop new things.
So we were doing service on equipment here in Fagersta, and then we were sending it to the mine. And that demanded a specific process.
Since we couldn't go to the mines to do the field testing, we started developing new technologies.
We found a sort of a pickup point. So we identified a place where we could place all the drill bits. And then we had a technician from Fagersta that went there with serviced drill bits, and then he collected the ones that needed service. And then from the mine perspective, they also agreed to place all equipment at this position where we could access.
You know, in the end we managed to collect our data successfully.
We had to concentrate more on building software and building frameworks than building or testing on actual vehicles.
We all coped with the situation, and we handled it according to what was required actually. I mean, strange times, but we did cope with it.
Modern technologies rapidly transform our world, and the mining industry is expecting significant changes.
So I think the industry will change. It will for sure become a lot more high-tech than it ever have been.
Well, now everything is going towards digitization and automation, so I guess the future will be shaped with innovations and advances in the current technologies.
The future will include more autonomous vehicles in the mine, less people down in the mine itself.
I think in the future, many of the dangerous work in the mining will be replaced by machines.
I also think that it will be a lot less people, maybe not in the industry, but down in the mines.
In general, live work, elimination, safety and environment are focus areas that will really drive development in automation, digitalization and electrification. And I think it's clearly where the mining industry is heading.
Interesting technology in the future that Benedict probably will work with is IoT, of course, and maybe also artificial intelligence.
Personally, I'm really interested and I like technologies that are replicating what a human being can do, meaning that we have solutions and technology that can make response-based decisions and act very much the same as a human are doing today.
So this will kind of change the type of people that will be needed in the mining industry, not just miners, but actually a lot of IT and computer science people.
At which pace, for example, robots will be replacing miners, maybe it's still not very clear, but it's happening already.
Humans, I think, will go from having today more of an operational role to more supervising and making sure that the equipment is running and behaving the way it should.
We will be basically able to see surrounding rock in the real time. We will be able to monitor the drill bit trajectory, and this all will be not only helping in guiding the drilling programs, but it will also significantly reduce risks and costs associated with that.
Simulations will play a big part in both monitoring vehicles with digital twins. It will be used to train machine learning algorithms. And I think it's also a great opportunity to make mining possible in places other than Earth. You can simulate a mining facility on other planets or on asteroids and do those kinds of developments before you actually go there.
After 2 years of work, the SMIG project has reached its end. It's time to sum up the results and to think about the future.
It was absolutely important for us to be in this project.
SMIG has meant a lot for ThingWave.
Participating in the SMIG project was very beneficial for Uppsala University.
It's been a great experience participating in the SMIG project.
I'm very grateful for the collaboration in the project, and I think that we have achieved a lot of things working with other partners.
We have managed to grow in large part thanks to SMIG. SMIG gave us access to mines and also a lot of very competent people.
We've learned a lot from this project.
I think the SMIG project will continue.
We would like to have a continuation of SMIG because for us it's been incredibly beneficial.
And hopefully we will continue to work after this project with these partners.
We hope that we will be able to do those things that we were not able to do in this project because of COVID.
There is still a lot to develop. We would like to advance our methodology and bring it to a more automated level.
We had a lot of really good ideas that turned out now in the end, so we really want to continue with those ideas and see how we can take them to the market.
I think it will be very successful, especially if it finds a format where we can run proof of concept at the mine site, for example, and we can do it where it's needed and make a proof of concept and then make it in a way that it's scalable afterwards. Then I think it will be very attractive to the mining industry.
We receive positive feedback from our partners, and they are encouraging us to continue the work.
The SMIG project was highly appreciated by the participants. and works towards the goal to establish a permanent organization that will be a single point of contact for various actors of the mining industry. We appreciate your support and thank you for being with us.
This is why SMIG
Get access? No, sorry, they don't get access.
When I was in the mine, I almost died. Well, maybe not died, but it would have been a very bad day.
We had one broken cable, we fixed it. No funny story, so better to skip it.
Skip that.
La 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 la.
This will, damn it.
I'm super smart. I don't think I should tell that.
First take.
That's it.